Okay, we've got a situation involving cluster sampling. So let's read this carefully. Let's do our underlining of the key information. So we are going to take a random sample of schools and then a random sample of students within each school. Okay, so do all people have an equal chance of being selected? Well, let's think this through. So I'm in a particular school, and the schools that are going to be used as the clusters are being chosen at random. So if that happens, then my school has got just as good a chance as anyone else's school being chosen. And then I have got an equally good chance of being chosen as anyone else at my school. So that makes it sound like I do have as good a chance as someone else, but suppose that someone's at a different school. In fact, suppose that someone is at a smaller school. If I'm in a school of 1,000 pupils, then in that second stage I've only got a 1 in 1,000 chance of being selected. And if someone's at a really small school with only 50 pupils, they'll have a much better chance, 1 in 50, of being selected. So the answer to this is no, unless all the schools are the same size. In other words, the same number of students. And if you're saying that the chances are not the same, you have to give an example of who would have a better or a worse chance of being selected. So in this case, we can contrast students at two different kinds of schools. So a student at some kind of school has a better chance of being selected than a student at what kind of school. So we can insert large and small the right way around in these gaps. So think carefully about which one it is. The student will have a better chance of being selected and it's a small school. Because in a small school, my school's got to be chosen anyway, but then if there aren't that many other people at my school, I've got a better chance of being selected than if I was competing with lots of people, which would be the case at a large school. Okay. All right. So in the context of our sample of students within the maths department, if we've chosen a timetable block, we could take a random sample of size 30. We've got to say how we would do that, and then we've got to explain why that could be a part of a cluster sampling process. Okay. Well, the first bit, a random sample of 30 from a timetable block. Here are the normal set of bullet points you use. In order to get started for the first one, you do need to know how many people are in that block. Anyhow, I'm going to go on to the second question. Explain why this could be part of a cluster sampling process. Well, what are my clusters here? My clusters, okay, are my blocks on the timetable. Okay, and so what we could do is we could choose, what do we do with cluster sampling? So that's at the top of the page. We choose a random sample of just our clusters. So here I choose one block, or maybe more than one block. So I choose one or more block at random. And then this thing was how I do a random sample within that block. And that completes cluster sampling. So I'd choose some blocks, in other words, my clusters at random, and then I'd choose at random within the clusters. So choose a simple random sample from each block. So that shows me how this could be part of cluster sampling. So you fill these in using the details from the data that you've got, and you've got previous examples of the bullet points you need to set up for random sampling in your notes. Okay, I'm going to move on to the next bit. If the population is all students in the maths department, then we're going to say, we've just said how we could do cluster sampling. What's the advantage of doing cluster sampling using timetable blocks? Well, what I need to do, having sorted out my sample, is I need to collect data from that sample. Why, if I've clustered on timetable blocks, will that be an easier process? Because, especially, suppose I've just chosen from one block. It means that block is on at a particular time, on particular days. I can go along at that time, on that day, and get all the data I need. So it's easy to collect data because the students from any particular cluster will all be in the maths department for their maths lesson at the same time. Okay, but then I've got to state an assumption we must make for cluster sampling to be appropriate. Okay, so why this is a general principle for cluster sampling. If you're only going to choose a few particular clusters and take your data from those, you've got a big risk of your sample not being representative. Okay, if all the clusters are very different in the kinds of individuals in them, then the luck of the draw of which clusters you choose could radically affect your data. So in order for cluster sampling to be appropriate, you want the contrast to that. Okay, so you'd like your individuals in each cluster to be, we hope, reasonably representative of the population. So we hope each cluster is fairly representative of the population. So assume all the clusters are similar and all are representative of the population reasonably, and that's probably true about timetable blocks at college, because we don't put particular students into particular blocks based on any kind of non-random process. The putting of students into blocks is a pretty random process, so we can assume that all of the blocks are similar in the types of students that will be in them.